This is the video for getting started in C. First thing you want to do with any program is copy and paste the starting code template from the Coding Standards document. So let me switch to Visual Studio to show you that. So I've currently got Visual Studio 2012 open, and we go to a new project. And as I demonstrated in the new project how-to video, you want to go to Templates, Other Languages, Visual C++, Win32, and then select Win32 Console Application. And you want to name your program something appropriate, and then put it in a directory that matches. For example, 1. So we'll just put it in the SET-151 directory. It will automatically make a directory for the project. I recommend against creating a directory for the solution. Creating a directory for the solution will allow you to have multiple projects in the same solution. You can have that anyways, but it just adds a layer of complexity to it that's not necessary. I'm a big fan of divide and conquer and doing one thing at a time, and I like one project per solution. It keeps it less complex that way. So I recommend against creating a directory for the solution. Go ahead and click OK. And go ahead and click Next. And you want an empty project, and you can turn off security development lifecycle checks. And again, we want a console application. We want it empty. Why do we want empty? Because this is boot camp. You're going to do everything from the ground up. And we wait for that to finish. Now mine's running in an emulator, so it's a little slow. Periodically I'll pause and cut out the waits like I'm going to do right now. So to finish creating the project, and if I go to my Solution Explorer window, a little slow there, I'll thumbtack it open. As you can see, there's several folders in there, and they are all empty. So we want to right-click Source Files, and we want to add a new item. You can also do this from the menu. Project, Add New Item. Either one is fine. And you want a C++ file. And we'll call this example 1 because this is just C, not C++. You got to remove the .pp extension. Go ahead and add that and wait. So we've got our file there. We can see it in our Solution Explorer, and it is empty. So I'm going to go over to the Coding Standards, which I have already downloaded. I'm going to copy that contents, and I'm going to paste it right here. And there we go. We need to put in your name, not mine, yours, unless you want to give me your grade. This is SET-151, and give me your section number. Probably it's going to be 40 if you're watching this online. This is an example of getting started in C. Always given a little abstract. Now, I know what it does, and you know what it does, but the purpose of the comments is to train you into planning what you're going to do before you can do it. Of all the skills I could pass along to you, planning what you're going to do is probably number 2 on the list. Number 1 on the list is readability. If you can learn how to do just those 2 things, well, okay, I'm gonna add that 3 out because everything always comes in 3s. It's the best things. The 3 probably most important things I can teach you are number 1, readability. Number 2, plan what you're going to do before you do it. One of the things junior programmers always do first, junior programmers write comments last. Senior programmers write them first and then fill in the code. Why? It is the absolute most efficient, most professional way to do it. And the number 3, probably most important thing I can teach you, is divide and conquer. Keep it simple. Do one thing at a time. no fancy code. Now, those are all different ways of saying the same thing, and I'm going to demonstrate those to you over the course of this semester, little bits here and there in different languages. If you can do those things, companies and people on your team will love you. You will not have a problem finding and keeping a job and doing really well at it. Okay, so we've got the template in there, we filled out the details, and that's what we wanted to start with. Let's go back to our PowerPoint slideshow. Now, main is the hard-coded starting point for all C programs. So I'm going to switch back to the code and demonstrate that right down here at the bottom. We've got main. Now, in the new C project how-to, I talked about these different pieces. Includes our built-in libraries of functions that you can use. Constants, you should have some idea what those are from previous programming languages. User-defined types and prototypes are probably still a mystery to you. We're going to learn about user-defined types in, it looks like, according to the syllabus, probably around week 9 or 10. Those are a long way off. We're going to learn about prototypes, which are for procedures, in about week 4. So down here is main, and this is where I said the program starts. Let's go back to our slideshow. There must be one and only one made procedure in every C program, and all code for a procedure must be contained within the beginning and ending curly brackets. So let's switch back to the code here. You can see right here I've got an open curly bracket and a closed curly bracket. If I try to put some code outside of that, it will most likely give me an error. Better. Oops, hold on. I accidentally clicked the wrong thing. Yeah, see, now I got the squiggly, the red squigglies. That's because it's error. If we highlight over that, it's, yeah, that's C's what, see, it's the error says this declaration has no storage class for the type specifier. That's C's way of saying you did something wrong. All code inside every set of curly brackets should be indented 1 tab. So you can see here I've got an indented 1 tab. That's 1 tab. There's 2. There's 3. Now if you indent too much, you hold Shift Tab and back up. One of the cool things you can do is you can highlight multiple lines and hit Tab and indent it all in, or you can hold Shift Tab and unindent. Isn't that cool? Now, why should the code be indented 1 tab? Well, let's see what happens if we don't. Alright, and then let's make it cryptic. Let's put it all one procedure, and then we can bunch a whole bunch of those together, and it starts to look really busy and hard to read. Now there's a saying, some people say it's hard to read, or it's hard to write, so it should be hard to read. I disagree entirely. Companies hire you to do a good job, the best you can, on whatever assignment is you're working on, and you are morally obligated to do right by them because they pay you. As soon as you cast that check, then you accept responsibility, or you take you fully accept that burden of responsibility. All right. Now, one thing I want to make clear: remember, you are not the owner. Any code you write for company is not yours. So you don't own the code because you got paid for it. You are the author. Never become emotionally invested in the code and think it's yours. You're always writing it for somebody else. Alright, so indenting is called 1 tab is called indenting to show scope, and it allows the reader to easily tell where the procedure starts and ends. Prerequisite for this course is IT 101, so I'm assuming that you know what procedures are. You may not be the best at them, but that's okay. You have some idea of what they are. Of course, making procedures in C is a little more complicated. That's why we'll have to learn more about C before we can start using them. The most important goal on any project is readability. If you can't understand it, you can't maintain it, upgrade, change, or debug it. In this course, there will be a strong emphasis not only in learning and writing C code to solve problems, but also writing code that is readable. The reason I put such a strong emphasis on readable code is because it helps eliminate so many problems. The effort you put in to make your code readable easily pays for itself. Most of the time, readable code pays for itself in all the technical support calls you don't have to answer. Every bug in your code has the potential to generate 1 technical support call per customer. If each technical support call takes just 30 minutes to answer, which really isn't that much time, it wouldn't take that many calls to fill up your whole day or even your whole week. The coding standards I show you in this course are designed to make your code readable so that you have less bugs and therefore less technical support phone calls. And I think everyone can agree that's a good thing. As I stated in the new C project how-to video, you must build your code before it'll run. The process of building translates your source code into machine code. Source code is what we write. Usually it's in a high-level language. A high-level language is more English-like. A low-level language is more machine code-like. It's easier to write code in a high-level language, but it is less efficient. C tries to strike a balance between ease of writing and efficiency or control of resources. There are two types of programs that translate source code into machine code: compilers and interpreters. Compilers translate all your code at once and save the results in a file. That file is usually an executable file with a .exe extension. Interpreters translate the code one line at a time. With interpreted language, each time the program is run, the code must be translated again. That's why C is a compiled language. It does that work once and then saves the results of the work. Next, we need to learn about variables. Variables are containers that store data. Before you can use a variable, you must declare it. Declaring a variable lets the compiler know you're going to need some space for your container. It will execute the instructions necessary to allocate memory. The generic syntax for declaring a variable is data type and then the variable name followed by a semicolon. I recommend you always initialize your variables to a 0 value when you declare them. There is no default value for a variable in C. Why? Because C doesn't do anything for you. If you want an initial value, then you have to do it yourself. The syntax for declaring a variable and initializing it is data type, space, then variable name, then an equal sign, then an initial value, and then a semicolon. The placeholder that I have up here in the slideshow is for data type, and that can be any valid C data type. A few of the valid C data types that we're going to be using are short, integer, long, float, which is it really should be single float, and double, which should really be double float, char, and boolean. Short, ints, longs, and are integer data types, meaning they store whole numbers only. They can't store decimal types. Float and double are what are called a floating point data types. A floating point data type can be represented with the following form. You have a certain number of significant digits times a base to an exponent. For example, 6.02 times 10 to the 23rd for Avogadro's number. Now, a single float data type always has 7 significant digits of precision. A double float data type has 15 digits of precision. Since a double can store twice as many can store value with twice as many significant digits, it's called a double. Look up significant digits on the web if you don't know what those are. You should have learned about those in math class. The char data type stores any valid character. The bool data type stores a 0 or 1 to indicate false or true. It's important to understand the range of values that can be stored in any variable data type. Your first homework is designed to teach you the limits of some of the different data types. So back to the example, or back to the syntax for declaring a variable. It's data type, variable name, equals, and then an initial value. After the data type is the variable name. Variable names must begin with a letter and can't contain any special characters or spaces. That is a rule. That's something you have to do. The initial value can be any valid value for the specified data type. I recommend that you use 0 most of the time. So let's switch to our code and try that out. So we've got our printf statement here. I gave an example of how that works in the new project how-to, but I can say int and then int value, and that's how the minimum syntax, and I can put a initial value of 0 after that. I'll go ahead and from the menu I will build, and it builded successfully, and in my error list I have no errors. Now remember, if you don't have the error list, go to View and Show Error List. Here are some examples for declaring variables you'll see on the web or in books. Short s equals 0, int I equals 0, float j, k, and l. Those variable names are all bad. Why? Because they aren't readable. In this class, you must use the following coding standards when naming variables. Boy, that sounds like a great surprise unannounced quiz question, doesn't it? All variables need descriptive names. That means no single letter variables like I, j, k, x, whatever. No abbreviations. That means you can't have min, max, average, calc, or anything like that. No abbreviations. Proper case. So we capitalize the first letter of each word. For example, first name instead of first name. Notice the F and N for the first name are capitalized, and here they aren't. Prefix. We use the Hungarian naming convention prefixes. You should have learned about those in Visual Basic. The variable prefixes are listed in the coding standards document. They're pretty intuitive, so you shouldn't have much trouble memorizing those. Let's go take a look. So here they are. As you can see, we've got all our variables, and eventually when you get to C#, here are the prefixes for controls, but we're mostly going to concentrate on just the ones in variables. So there they all are. I've listed them all out and what they should be. Also notice up here in the coding standards I talk about descriptive names, abbreviations, proper case, and prefixes, and I give you example all those, and I even tell you to initialize variables because there is no default value. Oh, interesting. So all of that stuff is right there. Now I didn't even really need to go over that because I know you all looked at the coding standards and read through them, right? Yep. Now some people don't like to use prefixes, and when I say that they don't like to use prefixes, I mean they really don't like to use prefixes. They say they get in the way or they aren't needed. I recommend prefixes because they allow you to easily tell the variable data type without having to look at the variable declaration. This is very useful, and it doesn't take much work, especially when you have something like the autocomplete feature. So for this class and all of my other classes, you will use prefixes. All right? Why? Again, they are useful. They tell you the data type without having to look at the declaration, and they are low cost. Constants. The syntax for declaring and initializing a constant is almost the same as for a variable. The only difference is the const keyword at the front. Now you must initialize constants, and after you assign the initial value, you can't change it. That's why they're called constants. You'll get a compiler error if you attempt to change a constant variable. So let's switch to our code, and I will now change this to a const, and I will try to modify the value. Expression must be a modifiable variable. See, it gave me the underlined squiggly. That's the IntelliSense. So let's zoom in on that. By the way, you can increase the font size is I always hold Control and then scroll the mouse, but you can also click here to zoom in and out. I think you can even put the focus in here, and you can have some. Yeah, you can have whatever percentage you want. So 109 is definitely not in the list, but we can get it in there if we want. So let's go put that back to a nice even multiple, 110. Now constants, according to the coding standards, let's go back there. Constants should be in all uppercase with words separated by an underscore. The prefix is always lowercase. That's how you tell the way you tell the prefix ends is the first capital letter. So prefixes are almost always lowercase, and the letters or the words in a constant are uppercase. So in my coding example, if I would lose points unless I made that int value to indicate that is a constant. Now later on, if we're looking in the code and we see a variable int value, we realize that because it's all uppercase, we cannot assign it or change its value. And that is the purpose of using all uppercase. Oops. Assignment operator. After you declare variables, you'll want to do something with them. Use the assignment operator to change a variable value. The syntax for the assignment operator is variable equals value or variable or expression. You can assign a hard-coded value to a variable, the value in another variable of compatible data type, or the result of an expression. So if I have the example down below, I declare three variables, value 1, value 2, and total. In the first one, I assign a value of 5 to value 1. That is a hard-coded value example. 5 is hard-coded. Into value 2, I assign the contents of another variable. So value 2 now stores 5 as well. And then in the last line, I have an expression. That's where you have 2 or more variables with a mathematical operator between them. So int value 1 plus int value 2. Expressions. An expression is a combination of values, variables, constants, or functions separated by mathematical or logical operators. Wow, doesn't that sound like a great surprise unannounced quiz question? The compiler follows the order of operations when evaluating an expression. The mathematical operators are addition and subtraction, standard plus and minus, times and divide, and a new one that you probably haven't seen before, which is modulus division, which is, and the way you do that, use that as a percentage sign. Now, that returns just the remainder. You're probably familiar, I said, with the first 4, but not the last one. Now, if we take 10 modulus 3, that's going to return 1. So just like you did in grade school before you knew about fractions and decimal points, you'd say 3 goes into 10 3 times with a remainder of 1. Well, all you want is the remainder part. How many times does 4 go into 7? Well, it goes in once with a remainder of 3. How many times does 3 go into 100? Well, it goes in 33 times with a remainder of 1. Oh, now this last one, some gargantuanly huge number. Oh, I don't even know how big that is. It's well over trillions, probably quadrillions or quintillions. If you divide that modulus divide by 2, the answer is going to be what? Anybody? 0, because it's an even number. Oh, and any even number divided by 2, by definition, is evenly divisible, so no remainder. Oh, isn't that tricky? Other operators. C provides other operators you might not be familiar with. Those are plus equal, minus equal, times equal, divide equal, and modulus equal. So, for example, int value plus equal 5 is the same thing as int value equals int value plus 5. The other operators work the same way. So let's go demonstrate that in the code. So I'm going to change my constant back to a regular variable, and I'm going to say int value equals 5. And so that's the assignment operator with a hard-coded value. And then I'm going to say int value equals int value plus 5. So now it should be 10. And I could do the exact same thing over again, but by doing plus equals 5. Now, if you're having trouble remembering those, guess what you get to do? You get to practice, practice, practice. Now, you may have also seen the plus plus and minus operators. I recommend against those because they are fancy coding. There's opportunities will come up later in the semester, and I will explain specifically why I recommend against them, but I recommend don't use them. What do you use instead? Well, it's int value. If you do plus plus, what that does is it just adds 1. So I recommend against using that and instead do int value plus equals 1. Same thing, and just slightly different. Oops. Go back to our slideshow. So again, I'll talk about why not to use those later in the semester. The order of operations in C is parentheses, multiplication, division, and modulus from left to right, and then addition and subtraction from left to right. There is no exponent operator in C. There is an exp or exponent function in the math library, but not an operator. Now, in order to model real-world problems in C, you have to know the order of operations so that the formulas you type in are evaluated correctly. Single-line comments are created using 2 forward slashes. For example, // do the math. Everything after the 2 forward slashes until the end of the line is ignored by the compiler. Multi-line comments are created using a /* to start and an * to end. For example, all these lines belong to us. I recommend you use multi-line comments only for debugging. So pretty much you won't use them for anything permanent, just for debugging. We are going to use the printf function in this course for output. The syntax for the printf command is printf and then a format string in double quotes, then a comma, and then any optional variables. Every optional variable is separated by a comma from the next. Now you can have as many optional variables that you need. Realistically, you're probably not going to need more than 4 or 5. C makes it real easy to break up the lines, the printf statements into multiple lines. So pretty much it's always be just one variable per line. The format string can be any text. For example, I love Star Trek. The printf command does not automatically move the cursor to the next line after you finish printing. You must use an escape sequence to do that. Escape sequences take the form of a backslash followed by one or more letters. Use the /n for a new line. For example, I love Star Trek /n. Use /t for a tab. A list of all these escape sequences can be found in your book. At the time of this writing, table 3.2 held a list of them. Let's go take a look at those. So here's the book, and this is the online version. I provided links to that in not only the syllabus but the ebook software link section. And as you can see, /n is a new line, /t is a tab. If you actually want a backslash, it's //. The format string can also contain placeholders for variables. Here is a list of placeholders we will use for this class. You're going to have to memorize these, and they will probably appear on surprise unannounced quizzes. So %HD for short, %D for an integer, %LD for long, %F for float, %LF for double, %C for a character, and %S for a string. I wonder how you print out a percentage character. So here's an example using 3 integer placeholders. First, we need 3 different variables. So I make value 1, value 2, assign values of 5 and 10 to those, and those are hard-coded. And then I use an expression to assign the sum of those to int total. Then in the printf statement, I have my formatted string, and inside that formatted string I put placeholders. And as you can see, there is 1 there, 1 there, and 1 there. Now afterwards I have commas, and the commas separate the variables. The variables will be used in the order that they are written. So it'll put the first variable in the first placeholder, the second variable in the second placeholder, and the third variable in the third placeholder. It is important that you use the correct placeholder for the correct variable data type, or for the variable data type. This is where prefixes really save us. So we can see that these variables are integers, and that means the placeholder should be %D. Now I put the variables on a separate line and indented them for readability. Unlike VB, you do not have to use a line continuation character to continue a statement on the next line. The semicolon tells the end of the statement, so until it sees one of those, it knows that it's all part of the same command. You can use any combination of placeholders you want inside the format string, but you must make sure the placeholders match the data type of the variable that you supply. You must also make sure that you have one variable for each placeholder. C gets very upset if you don't give it enough variables. Now the order of variables, as I said, is significant. They will be used in the order that they are supplied. Let's go test that in Visual Studio. So switch over, and I'm going to replace what I got here, and I copied those values, and I have to indent them to make sure they look pretty. Alright, I probably want to indent one more there. And I'm going to go ahead and translate my source code into machine code. Hopefully I'll get no errors. And it's chugging along. It says building started, and come on. Is it finished? No, it's still thinking. And it's done, and now I can hit the green button to run it. And we can see that the output window has popped up. And let's go ahead and drag that down so we compare the code. It says the value 5 plus the value 10 equals 15. Oh, that is pretty cool. And we are well on our way to our first C program. We hit space to continue. Remember, the system.pause finishes that for us. So that's all I wanted to cover in this getting started video. That should be enough to get you started on the first homework. Now the first homework looks deceptively simple. I can assure you it is not. It will really challenge you. And that is the end of this video.